Hello, 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 hello. Hello once again, everyone. The content of this video will be more on how do we solve rational inequality. Yes, this is only the continuation topic of what we had before, which is solving rational equation. Now let me start the presentation. Rational inequality. Steps for solving rational inequalities. We have steps here to consider, and all you need to do is to familiarize the steps which will be presented in this video. Starting with the first one, rewrite the inequality so that there is a zero on the right side and change inequality symbols into equal sign. And for the second one, find the values for which the rational function is undefined and equal to zero. These are considered the critical points. And for the third step, the critical points divide the x-axis into intervals. And for the fourth one, select test values in each interval and determine the sign of the polynomial on that interval. If a point satisfies the inequality, then the interval to where it belonged is part of the solution set of the inequality. And for the fifth one, mark the number line appropriately to illustrate the entire solution set of the inequality. Use interval notation for your answers. So you have it there. 5 steps to familiarize. It may be lengthy. You might say it's quite long for you to memorize. All you need to do is to familiarize on how we do it, because we don't need to state the steps, but to initiate and follow the steps being presented. And let's have a short review on interval notation. How do we present interval notation? You have here the general rules for interval notation. Given interval notations, and then how it is represented into an inequality, and then how do we graph it in a number line. Okay, the open parenthesis -3, 5, close parenthesis. In an inequality it is just equal to x greater than -3 less than 5. And in presenting that one, it should look like this. The shaded part is located in between, and we don't need to shade, or we don't need to include the numbers -3 and 5 for the shaded portion, because that's the meaning, or that's how we represent the open interval, the parenthesis symbol. So that's the hollow portion. And for open parenthesis -3, 5, and then close bracket, it is equal to x greater than -3 less than or equal to 5. And for the graph of that interval or inequality, it looks like this. As you can see, the 5 there is shaded because it is a closed bracket. Closed bracket means that that number is part of the solution, okay? Which means 5 is part of the solution. Same goes with the other representation here. The bracket symbols are shaded portion of the number, and then open intervals or parentheses are the hollow parts of the graph. Okay, so you can pause this one and you can take a review on interval notation. Once you're done with the review, let's move on to an example number 1. How do we solve rational inequality given 2 over x plus 5 is less than 4 over 11? And for the step 1, all we need to do is to change the inequality symbol into equal sign, and then make sure to have 0 on the right side. And to have 0 on the right side, from this given, 4 over 11 is being transferred to the left. And as you can see there, that's positive 4 over 11. And as you transfer that to the left, it will turn into a negative value, which is negative 4 over 11. And now we're done with the step 1. As you can see, we have a 0 on the right side, and then from inequality symbol, it was changed to equal sign. And for step 2 is solving. Now, we are going to solve it by finding first the LCD. Okay, just the same process with solving a rational equation. We find here the LCD, and in this case, our LCD will be this one. Okay, that is our LCD. 11 times x plus 5, because our denominators are x plus 5 and 11. For us to make sure that the LCD is divisible for both denominators, then it should be the multiplication of both denominators, or let's just multiply both denominators so we could get the LCD. And after that, we apply the process, okay? So that's gonna be before doing that, I can also substitute, I can also distribute 11 to x and 11 to 5. So as you can see it here below, it is now 11x plus 5 on our denominator. And after that, we apply the step, okay? So how do we get the numerator value? If you're asking how do we get this one, okay, going back from our step 1, let's look at that. 11 times x plus 5, or the LCD, divided by x plus 5. That's gonna be, we can cancel out there x plus 5 here. X plus 5 will be canceled. And then, the remaining value will be 2 times 11, because we still have 11 on our LCD. Next will be the second term. LCD divided by 11, so which means we can cancel out 11. So on the LCD, the remaining expression will be x plus 5 multiplied by 4. So as you can see it here above, that's negative 4 multiplied by x plus 5. And after that, we are going to operate the following. 2 times 11, that's 22. This one. 2 times 11, 22. And then, negative 4 times x, that's negative 4x. Negative 4 times 5, that's negative 20. Therefore, we already have the numerator and then the denominator. And after that, we're going to combine like terms. So what are the like terms here, or what are the similar terms? We have negative 20 and positive 22. These are constant numbers. Okay, so we can combine them. 22 minus 20, that's 2. That's why on our numerator, the remaining value will be 2. And then copy negative 4x. And after that, we are now ready to identify our zeros by equating our numerator and denominator to 0. So starting with numerator, 2 minus 4x will be equated to 0, as you can see it here. And then we need to solve for the value of x. Solving for the value of x, that's going to be 2 is equal to 4x, because negative 4x will be transferred to the right. And then that's why we have 4x here. From negative, it becomes positive as we transfer to the right. And then as we solve for the value of x, we need to divide both sides by 4 for us to solve 1/2. Okay, I'm gonna show here. 2 is equal to 4x. As you divide it by 4, therefore, 2 over 4, that's 1/2, is equal to x. So that's the reason our value of x for the first 0 is 1/2. So here is the answer. After that, the second 0 will be the denominator. We equate our denominator, 11x plus 55, to 0. Okay, after equating it to 0, we need to find for the value of x. Okay, now we need to separate them from the left and from the right. And on the left, the remaining value will be 11x, and then positive 55. As you transfer that to the right, the sign will be changed. That's why we have negative 55 now on the right side. And then as we solve for the value of x, if you might be asking, sir, how did you solve their negative 5? That's gonna be 11x is equal to negative 55 divided by 11. Divided by 11, we cancel out 11, and therefore x is equal to negative 5. So that's the reason, because negative 5 divided by 11, a negative 55 divided by 11, the answer there is negative 5, and that is the reason why. Now we're done with our step 2. Again, we're still with our step 2. How about for our step 3? How do we do that on step 3? Okay, so for our step 3, that's identifying our intervals, and then we need to draw the notation, the number line. Okay, so here is the number line. Okay, let's now identify our interval. Okay, why do we create, or how did I create the number line? Based from our values of the zeros, remember that in our step 3, the value of our 0, the x there, will represent on how we divide the interval. Since x is equal to negative 5, we have here negative 5, and then we also have x is equal to 1 half, we have 1 half there. And in identifying the interval from this point going to negative 5, that is negative infinity, negative 5. So that's the first interval. The second interval will be here from negative 5 to 1 half, in the middle, that is negative 5 to 1 half. That's the interval. And then the last interval is from 1 half going to infinity. So you have it there, 1 half and infinity for the third interval, which means that the number line is divided into 3 intervals based from the zeros we get. Okay, and we're not yet done because we still have step 4 and step 5. Going to step 4. Okay, let me show you first the intervals, the 3 intervals. So in step 4, we're going to do the test points for each interval. When we say test points, I have here x is equal to negative 6. No? And if you might be asking, sir, how do I get the test points? Test points are points within the interval. Make sure that that point belongs to the interval. Okay, if you will say, sir, is negative 5 belongs to the interval? Yes, it belongs to the interval, but we must not include it because it is an open interval. Open interval means that negative 5 is not included. Okay, so we need to have less than negative 5 or greater than negative infinity. And remember that negative 6 is less than negative 5. Therefore, we can test that point to our original equation. Okay, we are going to substitute negative 6 to our original equation. And as you can see that, 2 over negative 6, because you have it there, x plus 5, 2 over negative 6 plus 5 is less than 4 over 11. And then we are going to simplify that. Negative 6 plus 5, that is negative 1. 2 over negative 1 is negative 2. 4 over 11, you can use your calculator, and that's gonna be 0.36. And you need to answer there the question, is negative 2 less than 0.36? And that is true. Take note that negative 2 is located on the left side of the line graph or number line, and 0.36 is almost 1, which means almost 1, that's going to be positive, which means that that value, 0.36, is greater than negative 2. So that is true. How about for the second interval? We have negative 5, 1 half. So we will get a point that belongs to that interval, and 0 belongs to the interval negative 5, 1 half. Okay, and again, if you might be asking, sir, can we have any number on any point in the interval? Yes, you can have 1, you can have negative 4, negative 3. I mean, not 1. 1 is not included because 1 half, I did not, I forgot that we have 1 half there. So, it should be less than 1 half. And take note that 0 is less than 1 half. Okay, so that can be, that is allowed for our test points. How about 0 0.4? 0 0.4 is also less than 1 half, so it's also okay. How about negative 1? Negative 1 is also okay, but in my case, I use 0 for us to solve the equation, the original inequality, easily. So let's substitute. So you have it there. Um, 2 over 5, no? If you might be asking, why is it over 5, sir? Because 0 plus 5 is 5. So simply that's 5 there on the denominator. 2 over 5 is less than 4 over 11. The answer there is false. Okay? You might use your calculator for the exact value of that fraction. Take note that 2.5 is equal to 0 0.4, and then 4 over 11 is 0 0.36. 0 0.4 is bigger than 0 0.36. That's why for the second test point, it is false. And when we say that is false, which means that interval, the whole interval there, the second interval, negative 5 and 1 half, does not belong to our solution. And going to the third one, test point for the third interval, you have it there, 1 half and positive infinity. And then I choose 2 for my point. So that's going to be 2 over 2 plus 5 less than 4 over 11. And then 2 over 7, in your calculator, if you indicate 2 over 7, that's going to be 0.1, 0.2857, and so on. But we can round it off to 0.29. And in order to identify whether it's true, 0.36 is greater than 0.29? Yes. 0.29 is less than 0.36. The answer there is yes. Therefore, it is true. Now, we are ready to proceed with our step 5 to draw our solution. Take note that the second interval is false, which means that this is not part of the solution. This is not part of the solution. And for our answer, which interval whose test points are true, then that will be our solution, which is negative infinity to negative 5 and 1 half to infinity. Why do we use union? Because it is like, as to review in our set, we need to make use of union for us to join them. And for the last one will be this. And take note, since negative infinity to negative 5 is the solution, this part should be shaded, okay? And still it's a hollow, take note. And then the middle one is not shaded. And here will be shaded because these are part of the solution, so they should be shaded. And that's how you present your answer from step 1 to step 5. Okay, let's have another one. Example number 2. So for example number 2, the given is x plus 3 over x minus 4 is greater than or equal to 0. So that's our inequality. Take note that on the right side, we already have the value 0, so we just simply change the inequality symbol or inequality sign to equal sign. And after that, since it's already expressed our numerator and denominator, we don't need to combine them because that is the simplified form. We are ready to find for the zeros. So for the numerator, x plus 3 will be equated to 0. Then that's gonna be x is equal to negative 3 for the numerator. And for the denominator, x minus 4 equated to 0, and if finding the value of x, that's gonna be 4. After that, for our step 3, the intervals are the following. We have negative infinity to negative 3. We have negative 3 to 4, and 4 to infinity. If you are asking, sir, how is in your number line the negative 3 there is shaded? Simply because take note that when we have an equal sign, that's automatically one of the zeros there can be or might be part of the solution. So we need to confirm first. Negative 3. So we need to substitute negative 3 to our original inequality. So that's going to be negative 3 plus 3 over negative 3 minus 4 is greater than or equal to 0. Negative 3 plus 3, that is 0, over negative 7 is greater than or equal to 0. So that's going to be 0 is greater than or equal to 0. Since this is true, therefore negative 3 is part of our solution. That's the purpose of having a shaded portion in our interval interval here in the number line. That's why the negative 3 here is not shallow but shaded. And 4 there should be shallow because take note that 4 will make our denominator 0. For example, let's substitute 4 on the denominator. It's going to be 4 minus 4. Automatically, the denominator is 0. Then, therefore, it makes our inequality undefined. That's why it's automatically not part of the solution. And then you have it here, the interval already. Negative infinity to 3. So from here, here going here. Negative 3 to 4 from here in the middle. And then 4 going to infinity from this going here. Now moving on to step 4. We're going to test the points of our interval. Starting with the interval negative infinity and negative 3 bracket. So testing the point negative 4 belongs to that interval. Therefore, x plus 3 over x minus 4, and that's gonna be greater than or equal to 0. Okay? And since in our original graph, original inequality, it is okay. So here we go for our test points. So for our test points here, we substitute now negative 4 to our original inequality. So x will turn to negative 4 and negative 4 here also on the numerator. And then we are going to simplify that. Negative 4 plus 3, that is negative 1. And then negative 4 minus 4, that is negative 8. And the negative 1 over negative 8, that's equal to 1 over 8. Okay, for you not to be confused. Because negative divided by negative, that's a positive value. And 1 over 8 is greater than or equal to 0. Yes, it is true because 1 over 8 is bigger than 0. It's more than 1. I mean, it's almost 1. Greater than 0, and then that's going to 1. Now, let us proceed to the second test point, which is the second interval, this interval. So here is the second interval. I choose 0 because 0 belongs to that interval. Therefore, substituting 0, that's going to be 0 plus 3 over 0 minus 4. And then as you simplify that, that's equal to the negative of 3 over 4. So if you're asking, sir, is it okay to write the negative sign on the denominator? Yes, but if you want to look it better, this one is also the same, okay? And take note that negative 3/4 is a lesser value than 0, so it is false. And as you can see, this is not part of our solution automatically because it's a false on the test points. And for the third test points, we choose from the interval 4 going to infinity. And then 5 belongs to that interval. And I substituted 5 here to our x. We have 5 plus 3, that is 8. 5 minus 4, that is 1. 8 over 1 is 8. And 8 greater than or equal to 0? Yes, it is true because 8 is a bigger number than 0. Now we're done with our test points or with our step 4. We proceed to our step 5. We can conclude that the interval negative infinity to 3 and then bracket union 4 to infinity will be the solution because these are the only interval where we get through on the test points. And then um, in this number line, the shaded portion are the following. So let me use now a black. So the shaded portion will be here, shaded, and this is shaded. Okay, so if your number line is not shaded, then your answer is wrong because you need to represent the solution into a number line and shaded for the solution part, because as you can see, we could identify which part of the interval will be part of our solution. Okay, negative theory is already shaded, no? So let me shade it again. So that's for the number given, for our given number 2. How about for the third example? We have it there, an inequality x squared minus 9 over x minus 8 is less than or equal to 0. Starting with step 1, as you can see, the right side is already a 0. Just simply change our inequality sign with an equal sign. And after that, the numerator can be expressed as x minus 3 and x plus 3 because it is just um, the sum and difference of two binomial. Okay? And as you can see there, as we proceed to step 2, we have the zeros. Okay, in our step 2, the zeros are x minus 3 should be equated to 0, and that's going to be x is equal to 3. X plus 3 is also part of the solution, and then that's going to be expressed to 0. We have it there, x plus 3 expressed to 0, x is equal to negative 3. And for the last one, the denominator x minus 8 is equal to 0, express as we express it to 0, and then the value of x will be 8. Now we have 3 points to plot in our number line, okay? And for our interval, that's going to be 4. Okay, look at how it looks like in a number line. So you have it there, the shaded negative 3, and then shaded 3. If you're asking why 8 is not shaded, because 8 will make our inequality undefined. Because as we substitute 8 as our value on the denominator, 8 minus 8 makes it 0, makes the denominator 0. Now we have 4 intervals here, from negative infinity to negative 3, negative 3 to 3, and lastly, and 3 to 8, and 8 to positive infinity. 4 intervals in this given. Now, for our next step is for the test points, starting with the first interval. Okay, again, we are still on our first interval, which is negative infinity to negative 3 bracket. Okay, so I chose negative 4 because it belongs to the interval, and it's easier because the number is not so big. So that's going to be x squared minus 9 as we substitute the negative 4 squared. Okay, why are you if you might be asking how it becomes 16, because that's going to be negative 4 squared minus 9. Take note that when you square negative 4 here on our numerator, negative 4 times negative 4 is positive 16. So that's the reason we have 16 there, minus 9 over our x is negative 4 minus 8. And then as you solve that, or as you simplify that, that's gonna be 16 minus 9 is 7. 7 over, that's negative 12. So you write here negative 12. And if you're going to write that value in our In our calculator, 7 over 12 is equal to 0.58333, and so on. And for its round, as we round it off, that's negative 0.58. And then the answer there is true because a negative value is less than 0. So that is true. How about for the second test points? So for our second test points, we choose the value 0 because 0 belongs to from negative 3 to 3. So it's in between them. So 0 is really okay. And as we substitute that, for our original inequality will be negative 8 over negative 9, I mean, over negative 8 is less than or equal to 0. And as you simplify that, that's going to be 1.125 less than or equal to 0. The answer is false because that value is greater than 0. And it is not also equal to 0. Automatically, this test point does not, or that interval does not belong to the solution. How about the next test point, the interval 3 to 8? I chose 5 there because it's easier. So as I um, substitute 5 to our original equation, that's going to be 5 squared minus 9 on the numerator. 5 squared is equal to 25. So as you can see, 25 on the numerator. And we are going to simplify them. 20, as you can see that, you can use also your calculator. 25 minus 9 is 16 on the numerator. 16 over negative 3. And then you can use your calculator again. 16 over negative 3, that's going to be 5.333. And it's a negative 5.333. The answer here is true. Okay. You cannot read the word because it's on white. So the answer here is true because the negative value is less than a 0. Now for the last test point, which is from interval 8 going to positive infinity. I choose 9. It's greater than 8 and it belongs to that interval. So we have it here, 9 squared. Okay, on your numerator, don't be confused. That is 9 squared minus 9. So that's 89 minus 9 on the numerator. And then we simplify that. 81 minus 9 is equal to 72. On the numerator, 72 over 1 because 9 minus 8 is 1. And then we're going to simplify and determine 72 less than or equal to 0. The answer is false because 72 is already a number greater than 0, and as you can see, it's positive 72, which means that it does not belong, this interval for this test point does not belong to our solution. So we only have two, which is negative infinity to 3, union 3, 8. Take note, guys, that in your answer, if you mistaken to write bracket here, for example, you're gonna write negative infinity and negative 3 open interval, this answer is wrong because that interval is different with an open negative infinity, comma, negative 3 closed interval. That is quite different. So please don't be confused in your solution. Therefore, in our graph, that's gonna be for the solution negative infinity to 3. So here, this is shaded here. And then after that, 3 positive 3 going to 8, so here. So these two intervals are the only solutions or part of the solution of our original inequality, and this should be the last part of your answer. Thank you so much, guys, and that's the last example we have. Thank you so much and keep safe always. Bye bye. And if you have further questions, don't forget to use our GC and the comment section below. Your subscribe and like is much appreciated.